In the first part of the question, I'm asked to show that the angle theta is 1.696. You can't use this number in your proof because you don't know it. You need to find it. So reformulate the question as, find the angle theta. If you are correct, you should get 1.696. With this question, the author wants to give you a chance to still answer questions B and C in the case you miss this angle. So even in the case you don't get this number, you should take it and use it in the subsequent questions. Hopefully we are going to get it. So angle theta is part of this triangle OPQ. So I need an equation to relate the angle and the three sides of the triangle because I know them. And the equation is given by the cosine rule. So I can write that 12 squared cosine rule equals making cos theta subject to the formula, I will obtain so cosine rule, making cos theta subject to the formula using inverse cos, and I get the answer. Question B asked me to find the perimeter of the shaded region. In order to find the perimeter, I need to add QP with the length of the big arc QP. The big arc QP corresponds to the angle here, 2 pi minus theta. So the angle 2 pi minus theta, with theta 1.696, will be 4.5871 to 4 decimal places. And this is what I'm going to use for the perimeter. So for the perimeter is theta over 2 pi times 2 pi r. 2 pi cancels, so it's theta times 8, which gives me 36.696 to 3 decimal places. I still need to add 12, which is the length of QP, so the perimeter is 36.696 plus 12, which gives me 48.7 to 3 significant figures. Last question asked me to find the area of the shaded region. So the area of the shaded region will come from the area of the triangle, which is half OQ times OP times sine of theta plus, so this is the area of the triangle here, plus the area of the big sector, which is 2 pi minus theta over 2 pi times pi r squared. Question 5 asked me to prove this identity, left hand side equals right hand side. I see right hand side is simpler, so I'm going to start to transform the left hand side, where I have a combination of trigonometric functions tan, cotan, sec and cosec. In the right hand side I only have sine theta and cos theta. So I'm going to change these four trigonometric functions only in terms of sine theta and cos theta. So I will add these two fractions on the numerator. The common denominator is cos theta sine theta. So I get sine squared theta plus cos squared theta, which I remember is 1. So I'm going to replace it by 1. Common denominator on the denominator is sine theta cos theta again. And now I need to divide these two fractions. So we divide the numerator. I replace sine squared theta plus cos theta by 1. So we divide it by the denominator by multiplying with the reciprocal of the denominator, and we end up with the right hand side. So we prove the identity. Tan x is given, and I need to find sin x and cos x. My angle x is between 90 and 180 degrees. So based on related angles, I will find the angle between 0 and 90 degrees, so in the first quadrant, having a positive tangent, and then I will move in the second quadrant to find this angle. So I am going to find the angle, let me call it theta, such that tan theta equals 5/12. My angle theta is going to be in the first quadrant, somewhere here. And then I'm going to move in the second quadrant, where is an angle that I actually need to find. So here is going to be theta, and this is going to be the angle x. All triangles having the same tan theta, right angle triangles, are similar. So I can just pick one triangle, right angle triangle. If tan theta is 5/12, I can consider this side being 5 and this side being 12. Of course, we can have other triangle, like with the sides 10 and 24, and so on, or 15 and 36. But all these are similar, so it's enough to take one. So in all these triangles, sin theta and cos theta will be the same. So let me take this triangle, let me call it ABC. From Pythagoras theorem, BC is square root of 5 squared plus 12 squared, which gives me 13. So sin theta in this triangle is 5/13, and in all triangles similar to this one. And cos theta is 12/13. Now let us remember that my question asked about angle x. And angle x is in the second quadrant, so it's between 90 and 180 degrees. Therefore, sine of x is still positive, so it's going to be 5/13, but cos x is negative in the second quadrant, so it's going to be minus 12/13.